This is 8.4, part 2. I'll explain what I want you to write down on this slide. Sometimes these rational functions have holes in the graph. They aren't continuous functions. They start and then they stop. So I want to have you highlight this piece down here. If you have a rational function where you have a common factor in the numerator and the denominator, then there's a hole in the graph at x equals b. So this statement right here is what I want you to write down. And then I'm going to show you an example on the next slide where there will be a hole in the graph in this rational function. All right, go ahead and write this example down. This is our last piece of the 4 things that we're going to find in a rational function. We've already focused on how to find the domain of the function, the vertical asymptote, and the horizontal asymptote. The last thing is to identify the hole in the graph. So what you do is you factor the numerator and the denominator. So the numerator can be factored using the difference of 2 squareds, x minus 3, x plus 3. And then the denominator is still just x minus 3. What happens is if I look at the numerator and the denominator, there's a common factor at x minus 3. So what this means then is there's going to be a hole at the factors. We have to solve this for x. I just lost my smartboard connection. All right. So what you do is you take that common factor, you set it equal to 0, and solve for x. So you have a hole in the graph at x equals 3. And on the next slide, I'm just going to show you what the graph looks like so you can kind of see. You don't need to write this down. Remember, we are not graphing these rational functions. So here's what it would look like if you had a hole in the graph. You'd have a hole in the graph at 3. So here's 3. There's where the hole, it would start and stop. All right. These slides don't write down. I just want you to kind of be aware of why we need to know these important pieces of the domain, the vertical asymptote, the horizontal asymptote, and holes in the graph. I have 2 pictures of some rational functions. Again, we are not graphing these until we get into pre-calculus. So here's a function, f of x equals 1 over x. And to graph this function, it has 2 pieces. It has a vertical asymptote. That's the vertical line in the green here. It's at x equals 0. And then there's a horizontal asymptote right over here at y equals 0. So they help draw curves in our function. The second example, the graph on the right, it's in factored form. Here's my function. And it has a vertical asymptote, this vertical blue line, at x equals 1. Remember, that's when you have it undefined. So just so you're aware, these are what the graphs will look like in pre-calculus. We have to know how to find these asymptotes in this class. All right, just a couple examples left and then we'll start done with our lesson. So here's what you'll see in your homework. We're going to give you a function and we ask you to find these 4 things: the domain, the vertical asymptote, the horizontal asymptote, and if there is a hole. Most of the time, most of these functions do not have holes in the graph. So we want to first, step 1, is make sure that our function is in factored form. So here's our given function. Let's look at the numerator. what can we do with the numerator? Well, we can take out a GCF, a 4. So we're left with x minus 3. Then the denominator is x minus 1. Now let's go ahead and answer the questions. The domain. Remember, the domain focuses on the denominator and what the restriction would be. So in that denominator, x minus 1, what can x not be? If I substitute a 1 into that function, it would make it undefined. So to shorten it up, let's go all reals except x can't be 1. So then the next piece is very quick. That vertical asymptote happens at the domain restriction. So x equals 1. So those two pieces come from the denominator. Now remember, the horizontal asymptote focuses on the degree of the numerator and the degree of the denominator. So let's just go back to the original function. I look at this x to the 1, and this is x to the 1. So my degree of my numerator equals 1. My degree of my denominator equals 1. If we go back a few slides ago to this chart, it is the middle one in the red. The degree of the numerator equals the degree of the denominator, so we divide by the leading coefficients. So the leading coefficients are 4 and 1. So we say y equals 4 over 1, or y equals 4. So now that is our horizontal asymptote. Our last thing is to see if there's a common factor. Is there a common factor, common parentheses in the numerator and the denominator? No. So there is no hole in this graph. Let's just do one more and then we're done. So here is a second problem. I'd say you can just kind of watch on this and listen. We have a function. We want to first factor it. Again, you're just watching. You're not taking notes on this one. So we factor the numerator. In factored form, we want to use the chart method. What are the factors of negative 15 that add to 2? Well, that's going to be a positive 5 and a negative 3. Now it's in factored form. So let's look at the domain. If I substitute a 1 into here, it would make it undefined. So my domain restriction then is all real numbers except x can't be 1. So then my vertical asymptote is that x equals 1. Now let's go back to the original function and identify the horizontal asymptote if it exists. So we look at the degree of the numerator. The degree of the numerator is 2. The degree of the denominator, that's a 1. So the degree of the numerator is greater than the degree of the denominator. So if we go back to our chart, you'll start to remember the chart when you do these over and over again. The degree of the numerator is greater than the degree of the denominator. We're right here. There's no horizontal asymptote. So we'd say none. Now we look at it in factored form. Is there any common factors? Any common parentheses? No. So what your assignment will be is a little different than what it says in the textbook, because we are not graphing these. You're going to do problems 8 through 16 and 23 through 25. You are going to find the domain, the vertical asymptote, the horizontal asymptote, and the hole for each of these problems. No graphing, no finding the zeros of the function like it says.